Hello, everyone. My name is Samir Buyiru, and I have the delightful job of presenting to you a couple of our strategic partners at Amazon Web Services for connected car applications. Uh, Delighted to introduce you to Peter Atala, who's the CEO and founder of Voxelmaps, and to Jeff France, who is the general manager of Verizon Location Technology, and who have been co-innovating with us in the automotive connected car space, where telcos and our automotive suppliers and AWS come together to deliver value to the end customer. So let's talk about what we do as AWS as a strategic cloud partner for automotive first. For over 13 years, AWS has delivered cloud services to thousands of customers worldwide. And we are the most broadly adopted cloud platform with an extensive global presence to launch and scale connected vehicle services wherever your customers actually need it. We have the broadest and deepest set of services that serve the connected car space and the CSP customers, such as Verizon, that serve the connected car space. Most global OEMs and tier one suppliers today run some sort of workload on AWS today. For example, in December, we announced a strategic partnership with BMW to accelerate data-driven innovation. And we've trained 5,000 plus BMW employees on AWS services. So we're super, super excited to bring our CSP partners like Verizon, our OEMs, automotive manufacturers, and our ISVs who are innovating on AWS like Voxelmaps together. In the automotive space, what does AWS do? We do a lot of things. We provide data place for automotive data. We provide machine learning services. We provide in-vehicle high-performance computing that do feature updates, that orchestrate all the different sensors, that provide machine learning at the edge. But today, what I want to talk about is the innovation that we've delivered with Voxelmaps and Verizon on ultra-low latency edge compute using 5G. So there are transformational business innovations possible by the development of the industry's first cloud-native 5G network edge. Bringing cloud at the edge with AWS Wavelength allows ISVs like Voxelmaps and enterprises like our automotive manufacturers to build new applications and run them closer to end users. With cloud-based 5G networks, we're not only helping telcos deploy networks faster than ever before, but we're ensuring that these networks can offer richer connectivity services on demand to the end user. So Wavelength is something that we've partnered with Verizon to deliver this added value, and Voxelmaps has provided all of the features that enable HD maps, high definition maps, to be delivered over Wavelength. So let's talk about what AWS does at the edge. AWS's position is that we are bringing infrastructure to the edge beyond regions and availability zones, as close to the endpoint as required by your workload, and with the same network, the same control plane, the same APIs, and AWS services in each deployment. If you need to run your edge applications with single-digit millisecond latencies to mobile devices like connected cars and to end users, you can choose AWS Local Zones or AWS Wavelength. Or if you'd like to run your applications on premises, you can choose AWS Outposts. But what we have done with Verizon is we have enabled AWS Wavelength. So developers such as Voxelmaps can build applications that deliver ultra-low latencies to mobile devices. So Wavelength has standard AWS compute and storage services at the edge of 5G networks. You can extend an Amazon virtual private cloud to one or more Wavelength zones. You can then use Amazon Elastic Compute Cloud, EC2, to run the applications that require ultra-low latency and a connection to AWS services in the region. What does that mean in a 5G network in an automotive context? Historically, when a car was connected to the cloud, it used to take over 100 milliseconds for that data to go to the cloud, for it to be acted upon and for that action to propagate back out to the car. Now, what we're doing with the Wavelength partnership with Verizon is we're actually providing compute and that decisioning capability at the edge of the network, right next to where Verizon has base stations, for example. And that reduces the latency into the low tens of milliseconds. And why does this actually matter for someone who's actually using this connection? So if we go into a real application, right, the distance traveled during 180 milliseconds is about 17 feet at 65 miles per hour, which is pretty common speed. And so 180 milliseconds is what it used to take if you were deployed in the cloud as opposed to in the edge on Wavelength. But now, because we can deploy the Amazon cloud at the edge, you can act within 20 milliseconds, which means that the braking distance, as soon as you detect something in the road, has gone from 17 feet down to 1.9 feet. So you can imagine how important this is for safety use cases at our customers. So I hope that gives you a good context for how we've actually implemented it and what we're doing together with Verizon and Voxelmaps. So I'll hand it over to my fellow presenters, Peter and Jeff. Please take it away.
All right. Thanks, Samir. So when I think about, our three companies coming together and what we can accomplish in the market, really three things come to mind in terms of how we create a safer future or, safer roadways. And first and foremost, I think, is location, right? If you think about, machines and their reliance on data-driven location systems to know how to navigate the physical world, it's extremely critical. And then where Verizon firmly plays is connectivity. So really, this is the communication between machines and people and the Internet of Things and the physical world. And then you think about mobile edge computing, which, this provides the ultra low latency, which is critical for the enablement of autonomous machines. And so really, Verizon has been a leader in 5G and MEC. And essentially what 5G and MEC provide are speed and processing power that enable capabilities that help make vehicles safer, including things like autonomous mobility, split-second decision-making, early detection, precise positioning, and prediction. And when you combine connectivity with the processing power of MEC plus location, this is really the formula for safer, more autonomous roadways in the future. And Verizon's 5G ultra-wideband network and AWS Wavelength, coupled with Voxel's location data, this technology and expertise are helping us reimagine the future of enhanced road safety. So Verizon's vision is ultimately to bundle services that today live native on the vehicles and be able to provide a better, richer experience by delivering them over the top of the network, leveraging MEC and 5G. So our work with AWS started a while back, but we were the first company in the world to launch mobile edge computing service, MEC, with AWS Wavelength. And then last year, we announced that we're working with AWS to bring cloud computing services closer to the edge of our 5G network. This is what we're calling Verizon's 5G Edge. And then recently, we also announced mobile edge compute is live for developers with AWS Wavelength at Verizon's 5G Edge in 10 cities across the US. And then with Voxelmaps, we've been partnering very closely with them as we participated in an MVP that helps create near real-time high-definition mapping platform. So creating HD maps is a very complicated process. There's a lot of data. There's a lot of processing of that data. And essentially what we're able to do is to take data off of various capture devices and bring that processing much more closer to the edge so that vehicles are then using more real-time information faster, quicker than weeks or even a month to get that data published out to those vehicles. And so when you think about automotive, Verizon is probably not the first name that you think of. And that's exactly what we want to change with a lot of these partnerships we're talking about with AWS as well as Voxel. And so when you think about where does Verizon sit in this ecosystem? We're really helping enable and bring the infrastructure for which these services are going to use and which these vehicles and machines are going to leverage. And so at Verizon, we actually have an entire team, our vehicle to everything or V2X team, that's focused on the R&D of this strategy. And then we also, with our infrastructure, can bring broad scale and different capabilities. When you think about safer roadways, this isn't just a single vehicle. This is, fleets of vehicles all across the nation. The infrastructure and the communications network that's going to be required has to be very robust. And then you think about for bandwidth intensive and latency critical applications, this is where 5G and wavelength are really enabling those services to be brought over the network. And so when you think also about connected infrastructure, we're also exploring different vehicle to infrastructure opportunities that leverage MEC and essentially thinking about how the street infrastructure communicates with the vehicles and vice versa. And these are areas where the local, state, and federal governments are already investing in this space. So then obviously, my team is the location team within Verizon. And so location is extremely important when you think about what we're trying to do and how we're going to enable it. And so as we are building these platforms and value added services on top of that infrastructure, it's going to be required that location is a key part of this. And that's where innovative smart vehicle and services are going to generate new revenue streams across the industry. And then, of course, as you start to have some of those services be delivered over the network, you're going to have extremely robust security for these connected vehicles. And that's something that Verizon has been in the business of with our current network business. And then our location team is also envisioning bringing new software packages to the market that are delivered over the network that help power autonomous vehicles. And obviously location is one of those services. And these are things that we're actually actively working on right now, which Peter will explain a little bit more in some of the things that we did with our partnership with Wavelength and Voxel. And so if you think about location, what does this do for autonomous vehicles? It allows them to be more aware of their surroundings, more aware of where they're at, what are other vehicles around them doing, and then communicating so that they're predicting and understanding their environment and making safer decisions, or the driver's alerted to these conditions and making safer choices. These services that we're talking about will include things like HD maps, which we'll talk a little bit more about, network intelligent routing, precise positioning, or object detection, and obviously there's a lot more. But in order to do this, these cars need to be able to localize, perceive, predict, and plan. So what does localize mean? It means we need to precisely and accurately position these vehicles on the road so they know exactly where they're at, what lane they're in, and then what things are around them, which goes into perceiving. So they know they need to have highly accurate and semantically rich data so that they can understand, exactly lane level positioning, identify lane boundaries, traffic signs, road objects, things like that. Then you need to be able to predict. So objects around them that are in their proximity, understand what they're doing, predict certain events so that they can respond, and then ultimately planning. So being able to safely navigate and seamlessly around different objects that they're detecting. So why do MEC and 5G matter? So Verizon is a leader in 5G, and we were the first in the world to 5G, and we continue to expand our network as a leader in driving 5G forward. We're focusing on building and transforming the 5G network so that different ecosystems can take full advantage of the robustness of our differentiated service. And then we continue to expand our coverage across the US. And then when you think about that combining with mobile edge compute, this enables services to run closer to the edge of the network. And this is going to allow very latency critical applications to run over the network and on MEC. And so MEC will also bring increased compute and storage. We can also shorten round trips to the cloud, slashing end-to-end latency and easing the transmission burden on the core network. And then we can also power near real-time communications with surrounding vehicles and the surrounding roadside infrastructure. And then edge compute is also a combination of partner-provided compute resources with AWS and connectivity for devices. So when you think about today and where computing power lies, it's largely within the vehicles. And so where it makes sense, we're looking to offload that compute power into the network, making these vehicles able to support low latency applications, as well as increase the bandwidth for richer experiences and more powerful use cases, and then offloading some of that compute power from the vehicles onto MEC. And so we'll talk a little bit more about how we did this with the specific applications which involved AWS and Voxel. And so with that, I'll hand it over to Peter to talk a little bit more about what we did.
Thanks, Jeff. It's a pleasure to be here today and have the opportunity to explain a little bit about the project that we've been doing with Verizon and with AWS. So when we think about Voxelmaps, everything that we do is around this concept of maps for machines. So I just want to explain what I mean by that. So human maps are something that we're all familiar with. These are the maps that are on our phones, in our cars, on the computer. And generally speaking, they're there to solve the problem of navigation. Navigation to addresses, that could be a city, a street, or even a building. Generally speaking, the data for human maps is pretty low resolution, 1 to 3 meters, and it's normally 2D data. Sometimes there's some aspects of 3D, but pretty little. When we start to look at maps for machines, this is very different. We're talking about building models which are true 3D data models of everything that we see, like a digital twin of the environment. And we're combining that with really high resolution, so 1 to 10 centimeters in terms of accuracy. So just imagine trying to map the world, map cities down to a 1 centimeter resolution. And it's not just about the location of these objects within cities, it's about all of the features, the measurements, the attributes of these objects as well. And by doing this, it creates a platform which powers autonomy, whether that's autonomous vehicles or delivery robots, or things like AMR, automated miniature robots, or even drones in the future. And at Voxel, we have a unique way of doing that. We have a voxel model. Voxel is just kind of a cube. And we create a model of the entire planet, a digital twin out of these very small voxels. Think of it as like a Minecraft version of the planet. But one of the subsets of data that we produce from this model is high definition maps for autonomous vehicles. And there's a number of reasons why high definition maps or HD maps are really important. The first one is accuracy. We need a map to be super accurate, to be able to localize an autonomous vehicle down to centimeter level position on the planet. They need to know exactly where they are, where they're facing. The second aspect is safety. So autonomous vehicles have a bunch of sensors, cameras, radars, LiDARs, which give them visibility of the environment. But there's always a limit to that range. And so, for example, their sensors might only give them 200 meters or so in terms of visibility. A high definition map allows them to see miles ahead, not just meters ahead. So in terms of safety and understanding, having that insight of the road and the road conditions, the HD map provides that. But one component that's really been missing is the concept of having real-time high definition maps. So it's one thing just to build a high definition map of an area, but we all know that roads change and road conditions change. So how do we capture that change, those changes that are going on, and deliver that in real time to the cars? So this was the project that we started to work on with Verizon and AWS. And I just want to explain the current process of how we build high definition maps. So there's kind of 3 core stages. The first stage is what we call the road data collection. So this is where we have a number of vehicles which drive around cities and countries collecting data. And on top of those vehicles, there's mobile mapping sensors. These are a collection of cameras, LiDAR sensors, and high accuracy GPS. And each sensor produces terabytes of information every single day. So up until now, it's not been feasible to try and transmit that data anywhere. So what we do is we offload the data into hard drives and we physically ship hard drives to data centers. So once the hard drive has arrived at the data center, we go into a pipeline of the production. So the first stage is to clean up the data. So this is where we take the raw data, we do data corrections, we align the data, we apply things like PPK corrections, which just improve the GPS quality. And then we merge that data together, particularly if there's been multiple passes of that data. Once the data is cleaned up, then it's over to the artificial intelligence. And this is where the AI then goes through the data and recognizes the key features that are of interest. And once it recognizes them, it performs a process of vectorization, which then produces a high definition map. That whole process from collecting data to producing that map is 1 to 2 weeks. 1 week if it's not very busy, 2 weeks if we get swamped with data. But even once we've produced that high definition map, we still need to get that map to an autonomous vehicle. And that process for a lot of autonomous vehicle companies is around a month, because of quality control and the ability to update. So the whole end-to-end cycle there is 1.5 months. So we were looking at, can we change that? Can we take something that takes 1.5 months and can we make it real time or near to real time? So in this project, what we did is we still had the same collection method. So we still had vehicles with the sensors collecting exactly the same data. But the difference here is thanks to Verizon, we had a super fast 5G connection. And we were able to take that data directly from the collection vehicle straight into the MEC. And so rather than having to even send that data across the internet to a data center, we could process that thanks to AWS and Wavelength right on the edge. All of the same level of processing that was done before is being done, but it's being done in seconds. And then once that's done and converted into a high definition map, we can then push that in real time to an autonomous vehicle. What took 1.5 months before takes 15 seconds on average now. It's truly game changing in terms of doing this. So I want to share a couple of videos just as a way of illustrating this as well for you. The first video you'll see is essentially an aerial view of one of our collection vehicles driving through San Francisco and collecting the data. You'll see that the data is appearing in real time. And it's not just collecting raw data, it's processing it. All of the different colors you see are the different features of that data set, all coming in 15 seconds at a time, across. Something that really hasn't been seen ever before in the industry. But if we zoom into that data, you'll be able to see even more detail. So here you'll be able to see the objects as voxels, but then overlaid, processed with the camera data. And once we have that, we then have the ability to apply the artificial intelligence to recognize all of the features and convert them to high definition map formats, vectorize them. And then we have the ability to choose which features we want. Remove the features that we don't need, if it's buildings or trees or lampposts or lane models, or put all of those features back. This can all be done within 15 seconds from collecting the data through to actually having the data fully processed. So, why do this? Firstly, as I mentioned before, high definition maps provide exceptional understanding of roadways, of cities, and of conditions, importantly, roadway conditions. But real-time high-definition maps allows autonomous vehicles to instantly learn about changes before they encounter them, miles ahead of the vehicle. This, in effect, gives the autonomous vehicle superhuman capabilities, and it makes it safer not just for the autonomous vehicle, but for all road users as well. And safety is the real key driver of all of this. And in the future, it will be possible then for the autonomous vehicles themselves to collect this data and to share this data instantly between each other. And that's only possible thanks to the great technologies from Verizon and from AWS. This isn't a science project. This is real technology that we've developed here at Voxelmaps that are being powered by Verizon and AWS that we can bring to the automotive sector, to autonomous vehicles, and make the world safer. Thank you.